Before we start talking about homework problems and how to do problems with percent composition, let's just really take a minute and review definitely what we're talking about here. This is not really a complicated idea. In any sample, and we can make believe this is a pile of chemicals or anything, but it's made up of some number of objects, and in this case I've divided them into, let's see, we have 4, 6, we'll make it 4 squares and 6 circles. So 4 squares plus 6 circles, there are a total of 10 objects. And we can define the percent composition. So percent circles, we'll call those circles, I was going to draw a circle, is going to be given by, well, I have 6 and 10 total, and because it's a percent, I'm going to multiply by 100%. 60% circles, right? That's it. If I have squares, percent squares, well, that's going to be 4 out of 10 times 100%. Now, that's the ratio. It's the ratio of squares to circles, and that's what the percent composition is. So now it no longer matters that I have 10 of them. I could have 1,000,000 of them. I could have 100 of them. I could have, if I had 100 of them, it would be 60 circles and 40 squares, because that's the percent. And that's all we're doing when we do this with atoms and molecules. Now, we'll use a different kind of sample, right? And we're still going to do the same thing. If we have, let's say, CO2, it's going to be made of, always in this ratio, right? It's CO2. So if I have 2 of those molecules, I'm really saying it's always going to be 2 atoms of C in whatever we're defining here, the total of whatever it is. And in this case, we're always going to use mass. That's where we're trying to find percent. So if we're saying percent, and it's by mass is what we're talking about here, of copper, we're going to say how many grams of copper in grams of the sample. Grams of the sample. Let me write that again. Equals grams of carbon, grams of the sample total. And it's going to be a ratio. And then the same thing is going to be true for O. So we're doing percent by mass. O is going to be grams of oxygen per grams of the sample. And they, in this case, because there's 2, it's binary compound, it's going to total be 100%. And I guess the key concept that you want to be critically aware of is that while we're not going to do this in terms of the number of atoms, we're not saying there are this many atoms to this many carbon atoms to this many oxygen atoms, but because each carbon atom weighs a set amount, our 12 AMUs, or 12 grams per mole, and each oxygen atom weighs 16 grams per mole, or AMUs. If we have a 2 to, the total ratio, that will set the ratio of the masses. So by just determining the masses, we are determining the ratio of atoms, and that's how we use this technique to find a molecular formula, because the mass comes from the ratio of the atoms, because each atom weighs a fixed amount. So to have a set ratio of masses means there must be a set ratio of atoms, and that is what a molecular formula is. Now let's just work one problem, and then we'll do a couple of problems.